Sounds good. I'll have to remember how to use Zoom. I think I share my screen. Yeah, that's the right button.
John, you want to say a couple of words before you hand it off to Chris? And
Indeed.
And I'll shut up.
I was going to say. So first of all, welcome to everybody. Thank you very much for coming out to what we're calling the Richmond, Virginia Salesforce developer user group meeting. But the reality is, considering the audience, this is the worldwide episode. My name, of course, is John Daniel, and my co-host is Ohad Adan. He is, of course, not in Richmond. He's in Israel, because that's what you do when you do the Richmond meetup. But tonight we obviously have a very special guest, and very excited to have him out. His name is Chris Peterson. For those who are probably, most everybody in the world knows him. If you don't, then he has been in the Salesforce arena, what, for 10, 11, 12 years, somewhere in that range now? And
15 now, yeah.
15 now? All right, it keeps growing every time I talk to you. You know, before working.
That's how time works.
Exactly. He started as Salesforce about 5 years ago. He's currently the, is it senior director, or your title keeps changing as well? So
just director for right now, but
just director. Sorry, just director. Okay, but if you've ever written a line of Apex code, you can thank this guy for making sure that it really does work and it behaves correctly and stuff like that. A little bit of background: before he went to Salesforce, he was in, he spent about a decade of Salesforce ISV dev experience, most notably at Financial Force was the last job that he was at before he went to the mothership. He told me that his Salesforce developer certificates have all expired, but he still has to review the certification test content on a periodic basis. And a fun fact, he has a very sassy lizard, and we'll just let him explain on that if he ever wants to get around to that. But with that, Chris, thank you very much for showing up, and you brought some guests with you, so I'll let you introduce those, but please take it away.
Yeah, so everybody gives me credit for Finalizers, and I definitely came up with the idea, but when I did, Srikanth kind of implemented most of them, so I think he deserves a whole bunch of the credit since he wrote the code to make them a thing and got them out the door. So Srikanth, do you want to introduce yourself briefly?
Hi everyone, my name is Srikanth, Srikanth Kanpur, like Chris said. I joined Salesforce Apex team a couple of years ago, and I'm enjoying the ride. I really love being part of the team and the company. And Chris started off, like he said, the Finalizers concept, and I had privilege to implement it, and looking forward to knowing more of all of you.
All right. You want me to just dive right in?
Yeah, because that awkward pause has got nothing to do, so just do it.
Okay. All right. So starting off with everybody's favorite, that John has already promised to digitally edit out, we have our forward-looking statement slide. You know the deal. Make all your purchasing decisions based on currently available features and not any forward-looking statements. Everybody needs, I'm sure, 10 minutes to read this and digest it fully. Wait, just kidding. It's burned into your brain already. So this is where normally we'd put the beta feature disclaimer right after the safe harbor disclaimer. But since transaction finalizers have gone GA, we're going to skip that. There is no longer a beta disclaimer. You can package them, use them in production. They're covered under your MSA. They're covered by support. They are a regular old Apex feature now. Huzzah.
Woohoo.
Huzzah.
So we're going to talk about the motivation behind the feature, some potential use cases, an overview of the design, the scope of what finalizers do, and a little bit about what they don't do, the limitations around them. We want to discuss via some code samples, some sample use cases that we've come up with and used as part of our testing and evangelism. We're going to make some time for Q&A at the end, absolutely. And I was also going to share some Apex roadmap highlights of a couple things that just went out the door, and another one that is going out the door soon, since what's the point of having a product manager on for a webinar if you don't have any roadmap presentation? That's what I'm here for, right? So Apex, historically, as of the time that we started talking about finalizers, had a problem. Async Apex is a black box. There's no easy way to retry jobs. If you're using future methods, you don't even get back an Async Apex job ID. So the best you could do is correlate by user ID and date time to try and guess which one was yours. This ugly fire and forget. Fire and forget's great if you can forget about it. But if it's something you care about, which it probably is, otherwise you wouldn't be doing it in like a transactional language like Apex, that's not amazing. You know, the user experience of your application is, uh-oh, something went wrong and I don't know what or why, other than taking a best guess at it. That wasn't the experience that we really wanted people to have. Thankfully, Queueables had already done something much better, which is give you back at least an async Apex job ID. But tracking the state of what was part of that async Apex job, you know, what record IDs were part of it, anything like that, really required you to build your own fairly expansive framework that only a handful of people had ever actually done. So in practice, people were using queuable jobs as still mostly fire and forget with a little bit of trivial error handling and reporting. This also means that if you do things like chain queuables, we advertise them as a feature in the Apex dev guide, but one limit exception in a chain breaks your chain. Very fragile pattern, very hard to recover from issues. And considering how hard it can be to predict certain categories of limit failures, that made chain queuable something of a liability and drove an over-reliance on batch Apex, which is much less parallelizable, much less scalable as an end user reactive framework. So we wanted to look at how do we get people to stop abusing and overusing batch Apex and leverage queuable more effectively. The ability to get insight into the status of your jobs, be able to do effective retries, were all a big part of what we got back when we started talking to developers about why they were using batch Apex so heavily. And then everybody's favorite topic, how do I log information or warnings when I'm working with callouts? I myself, the last thing I did when I was an engineer on the App Exchange team was write a batch Apex job that did one call out per execute. Is this an anti-pattern? Absolutely. But it was the only way I could guarantee that I could properly update the status of the custom object records that corresponded to that call out atomically. So it was what we did. The exact kind of abuse that we wanted customers to stop doing to batch Apex, we were guilty of ourselves. Clearly, we had to do some work here. So we solved the problem in winter 19 with batch Apex error event. Kind of, sort of. We're actually really proud of this. Batch Apex error event, for anybody who doesn't know, is if your batch Apex job implements an extra marker interface of database raises platform events, any unhandled exceptions in the batch Apex job, be they in start, execute, or finish, be they limit exceptions or GACs or custom exceptions, doesn't matter, fires a platform event that includes information like the record IDs that were being processed. That meant you could add a trigger on that platform event and build a fairly simple retry system. You could inspect the state of failed jobs and retry based on the fact that the record IDs are part of that event. You could build a flow that attached to this and notify admins. And a couple of releases later, you could even package these triggers and use this in an ISV application. Except this only works for batch Apex. And when we started looking at what we wanted to do for Queueable Apex, we realized that this pattern worked really well for batch Apex because Apex as a framework was managing the scope and feeding it to your execute methods. You tell us what query to run and start, we choose how to break it down and feed it back to you, which meant that we had a much more prescriptive framework where we could give you that information in the events. And this Chuck Liddell is here and he made sure that it works for iterators. Yes, iterators did work there, but there's character limits and you gotta implement toString, but they do work, Chuck. I know you're gonna ask.
Thank you.
It doesn't solve the problems of how to manage callouts though. It doesn't work for Queueable. And fundamentally, it requires Salesforce to have a much deeper understanding of the framework. And Queueable is far too freeform for this to be effective. You can already find the at least first 255 characters of a failure message for a Queueable job in async Apex job. But that doesn't tell you anything about what the scope of operation was being done on. And there's no way for Apex to really guess at the scope of operation other than serializing the whole thing. And that gets into a whole GDPR privacy security nightmare. So this was not the route we wanted to take. We were happy with what we did for batch, but it didn't solve the problems that we had for Queueable. So we rolled out transaction finalizers. Really the same problem domain, but with a framework that's much less prescriptive, that's much more freeform. And as we started looking at it, we realized that something that you could attach to the job before it fires wouldn't necessarily have the insight into the state of the job that something like a logging or a retry framework might want. The scope of what your queuable can do can vary depending on any number of factors. So we needed something that could actually be edited as the queuable was executing. And that's where this idea of a mutable finalizer object came into play. Before we get there, what really is a finalizer? It is an Apex object that implements the finalizer interface, which is one method, execute. That during a queuable job execution, you can register as basically a completion callback. If you're familiar with JavaScript and the promises style API, actually fairly inspired by that, and Kevin Foreman has done a version of promises on top of this. But fundamentally the same idea. When my job is done, I want this object to execute with whatever arbitrary state is attached to it. You choose what that state is because it's your finalizer object. And that checks those boxes. When a queuable job fails, now we have a way to retry, recover, or notify people, because that finalizer object could contain the full state of the queuable job if you wanted it to, or a subset of it, record IDs, whatever makes sense in your model, so that you're not passing around OAuth secrets unnecessarily, and those aren't getting dumped to debug logs, things like that. And sometimes these errors are non-recoverable, like limit exception, or even if Salesforce has a bug, that would never happen, but once in a while, the legends tell. A GAC. GACs are inherently non-recoverable. They're always fatal, just like a limit exception. So we needed something that could actually survive a limit exception or a GAC. So this can't be as simple as a finally block. That's not going to do it. This needs to be something much more advanced. So transaction finalizer takes your finalizer job, and when your queuable completes or fails, serializes it out into a brand new Apex execution and runs it there. So you get a brand new set of limits, and you get whatever state was on your finalizer object to do whatever you want with. That could be the full state of your queuable job, so you can do an immediate retry. In fact, you can implement finalizer and queuable in the same class if you want to make that easy. But at the end of the day, your finalizer can run even if your original queuable job Apex context is irretrievably hoaxed, like by a GAC, because it leaves it in a state where we have to roll back the database state. We're exfiltrating the Apex state of your finalizer into a clean new context where you can go and do whatever is appropriate. So use cases, re-enqueue, i.e. a retry, absolutely. That was one of the first ones we wanted to make sure worked. This is one of the reasons you can implement finalizer on your queuable job, is so you could literally just do system and queue job this as part of your finalizer if you want to do a retry. If you make them the same, it makes this pattern dead simple. It's so easy to do. You just add a second execute method to your queuable job. It's gloriously simplistic. A really popular one, logging, especially before platform events had the ability to fire it non-transactionally. There was no great solution for logging, because if you wrote to the database, that meant you couldn't make a call out subsequently. So you had to be very, very careful about logging to the database. So one of the patterns that we wanted to work here was making sure that you could buffer your log messages in the finalizer and have them saved in a clean context when the finalizer executes. So if your queuable job succeeds or fails, you don't care. You still want to write those log messages somewhere persistent. And because it's an in-memory buffer on that finalizer object, that just works. Great, very simple. And again, we talked about chaining jobs and the relative fragility there. If your queuable job fails, do you want to kill the whole chain? Maybe, probably not. Depending on what your answer is, you can switch between 1 or 3 or both. You can retry and then move on if it fails a second time. Whatever logic you want to encode in the finalizer to keep that chain going, or restart the chain, or fail the chain and surface it to an admin, you absolutely can do. You really have ultimately whatever freedom your implementation takes you down in choosing how to respond to failure now. And this is where I'm going to hand it to Srikanth, because he built this diagram and the code that runs it.
Hey, Chris, quick question on your last slide. The log buffer, do you mean, is that the Salesforce log, or is that a custom log?
I'm thinking custom object logging. The Salesforce debug logs, those are great for, I mean, printf debugging is an ugly term, but that's really what they are. The fact that they only write the logs anywhere when you're actively looking and have the foresight to set a trace flag means that they're a very bad idea for passive logging of the overall health of your system in production. Like when you reach out to Salesforce support, we go look at our passively collected application logs to see what's going on. We have logs that say a request came in and it started an Apex context and it did a SOCL query and it did a DML operation and then it completed, and these were the aggregate stats about the operation and its success or failure, things like that. And ultimately, we'd like to give more of that type of visibility and flexibility to customers the same way we use it. So yeah, custom. Does that answer your question?
Thoroughly. Thank you.
Okay, so let me walk you guys through this internal sequence diagram. So when a queuable is enqueued, eventually when it comes up for execution, the control is delegated to the queuable handler. Queuable handler, as you can see, gets the message to execute the queuable. Oh, can you guys see my mouse pointer when I'm doing this? No, not really, right? Oh, Chris is.
No, I don't think you can. You can see my mouse pointer.
Okay, that's good enough, actually. That's okay. So I'll walk through it while talking. So Queueable Handler gets the control. The first thing it does is it, oh, okay.
I'm giving you control. These crazy
right.
Zoom features.
So can you see my mouse now? Is that what it is?
In theory, but it doesn't look like it. All right, never mind.
Okay, that's fine. So Queueable Handler reads the queueable data from the database. That's the first thing, read job data. And it starts executing the queueable. So it creates the queueable instance. Queueable Handler is an internal process that's in the Salesforce runtime. After it reads the queueable job data, it creates a queueable instance. If you see on the top, the rectangular boxes indicate the internal processes that are in the Salesforce runtime, whereas oval shapes indicate the instances of the objects that customer has written, or you write the Apex code for that, your queueable class or your Finalizer class, an instance of that. So a queueable instance is created and it starts executing. Now, at the very beginning of the execution, if you see, there is an attach Finalizer call. What it does is, before attach Finalizer, you create an instance of Finalizer and then call the attach Finalizer. Here is an interesting that happens. At the time of the attaching a Finalizer, Finalizer state is empty. All it has is just a Finalizer object. But as the queueable is executing, it can mutate. It can change the Finalizer state by adding any data to it. Whether if Finalizer has a log buffer, let us assume that buffer is initially empty. The queueable can keep calling log method, which could be implemented on the Finalizer instance, and that could keep adding the strings that are passed to that method into the Finalizer's internal log buffer. The point to note here is, when a Finalizer is created and attached by the Finalizer, by the queueable, that is not the state that the Finalizer is likely to stay in. As the queueable keeps on adding data to it, the state changes. And when the queueable is completed, whatever state the Finalizer has at that time, that will be serialized and used later for the Finalizer's execution. So that's an important point to note.
That's really important. Like in most async Apex systems, when you say like in queue job for a queueable job, we serialize the object at that point in time, and subsequent mutations aren't impacting that state. For finalizers, they are explicitly designed, because they are designed to run after a failure happens at a potentially unexpected point, to be mutated after you attach them. So instead of serializing the finalizer state when you attach it, what we're doing is taking an object reference and storing that so that we know which object to exfiltrate from that Apex context and spawn a new one on top of. So you almost always want to mutate your finalizer after it's attached. That's a really unique aspect of using finalizers effectively.
Right. So once the queueable execution completes, the control returns back to the queueable handler. Queueable handler at this point of time delegates the control to Finalizer Handler. That's where it invokes run Finalizer Handler. The arrow goes to the Finalizer Handler. The Finalizer Handler has a reference to the Finalizer instance that's created in the queueable instance. So if you look at it, the queueable handler created the queueable instance. When the queueable instance is running, it created the finalizer instance, but that reference is passed to the finalizer handler. What finalizer handler does at this point of time is serializes finalizer at that point, whatever state it was containing, whatever state has mutated from the time finalizer instance was created till that point, it serializes it. After serializing, you see a blue dotted line which says release context. It is at this point the execution context of Apex, database context, certain other contexts, request context, certain other contexts, log contexts are released so that finalizer execution is completely independent of queuable execution. Why is that? Because if a queuable transaction has failed and queuable transaction has been rolled back, we don't want that state to influence the finalizer's transaction. You could have some DML in the finalizer, it runs entirely in its own database context. So this blue dotted line is after queuable completes and finalizer instance has been serialized, all the important contexts are released and new contexts are created. The Apex execution context, database context, log context, and request context. These are among few.
So Srikanth,
then-
if I boil that down, everything above the blue line is one set of Apex limits and one database transaction.
Yes,
We close those out at this first blue line and then set up a new set of Apex limits, statics, state, and database transactions at this lower blue line, right?
right, totally, yes. So the queuables limits are different from the finalizers limits. Of course, they both are async limits, but you're right, they're independent. So you won't be influenced by that. It's a fresh set of limits start. Now, the finalizer handler, what it does is it will deserialize the finalizer instance, which previously serialized, brings back the state that it was having previously, and then starts executing the finalizer. And once the finalizer execution completes, the control is delegated back to the control, execution control. So if you see on the database side, in the diagram, the database line, the orange bar indicates one database transaction context that is used by the queuable handler, whereas the green bar at the bottom on the database line timeline indicates the transaction that is used by the finalizer. So they both are independent transactions. The database transaction in the queuable, database transaction in the finalizer are independent of each other. Making sense? Okay. Any questions? We can go to the next slide. All right. So here is an example that Chris was referring to earlier, where your finalizer and queuable can both be implemented in the same class. If you look at it, if it is a queuable class, you will have an execute method that takes queuable context. Now it has an extra execute method, which is finalizer, which takes the finalizer context. So there are two execute methods because this particular class is implementing two interfaces, finalizer and queuable. The queuable context execute method here is not doing much. It is simply attaching a finalizer instance, which is itself. It's creating a new instance and attaching it. So when the queuable completes, that instance will be deserialized again, and it will check in the finalizer's execute instance whether the parent queuable job was successful or failure based on that it is doing some trivial operations here. This example doesn't do much DML or state mutation. All it demonstrates to you is that you can have both finalizer and queuable on same class, and you can check the parent queuable's state, whether it completed successfully or whether there was an error. Based on that, you can take different actions in that if block or else block.
And notably, you get access to the parent job's exception cause if there is one.
Yeah. And if it is a custom exception, something that you're expecting, you can actually check for that and have custom actions based on that. So one question was, do finalizers count against async apex limit? Yes, finalizers run with async apex limits, but those async apex limits are different from queuables.
Yeah,
ahead, Chris.
so Chuck, I think you're asking about the daily asynchronous apex limit,
The 250K.
like the total number. Yeah, so they do not count as an extra asynchronous process against the daily async apex limit.
If you re-enqueue the job, does that count?
Yes. So if you're using a queuable, a future, anything else that counts, those count like they normally do. But the finalizer's execution, because it's piggybacking off its parent queuable, isn't its own async context that we considered. Like we didn't want to penalize you for implementing a logging system. Like doubling your limit consumption for that would be
That was
unfair.
exactly my concern. Thank you.
Right.
Yeah.
The second question.
So what we did do, sorry, Shrikant, what we
Yeah.
did do, and this comes up in just a second, but I'll answer it here since we're already on the topic, is make it so that finalizers use limits that are much closer to the synchronous apex limits. So in async context, you get double the heap. Finalizers, you get double the heap still. And that's the one place where we use the more generous async limits, is because we didn't want your finalizer instance to immediately blow the heap limit once we restored it and started executing it. But for CPU, for DML, for Sockle, it uses limits that are basically the synchronous limits. So you get the lower CPU limit, you get 10 seconds instead of 60 seconds as a CPU limit, things like that. So instead of penalizing you for using finalizers, we wanted to make sure that they were fairly lightweight enough that they didn't need to be counted heavily for fair use and things like that.
And coming to the second question, what is the delay timing from the queuable to the finalizer firing? Right after queuable completes, finalizer gets executed immediately on the same thread, so there is no delay.
Yep.
So the
Yahoo.
next slide.
Wait. So I thought there was and maybe this is my own ignorance here. I thought there was a limit to the number of simultaneous executing queuables in an org.
There is not on queuable. There is an undocumented.
I know there
limit.
was on batch. Yeah.
Yeah,
There is
there
on
is on
batch, yeah.
There's an undocumented concurrency limit on future that I only learned about the other week. It is high enough that it will probably never come into play. There is not a org concurrency limit on queuable. That said, the underlying message queue that we run on top of does have fair use and throttling. So if your org starts to monopolize processing and somebody else's queue gets held up because of it, it will start to slow down your jobs for the sake of giving other people fair access to resources. So if message queue starts getting a resource crunch and you're the one hammering it, it'll make sure everybody else gets a fair shot at using resources. But there is not a per org maximum concurrency on queuable. And a common misconception, there's not a per org in queued limit like there is with batch. Like with batch, you have 5 running, you have 100 in the flex queue. There is not a maximum number of waiting to execute queuable jobs per org.
Okay, then also, what's the I guess a comparison of the delay and the timing from the finalizer picking up versus a platform event listener picking up on a platform event message? Are they similar in respect, or faster? One's faster than the other? What's your thoughts there?
Finalizer is going to be more reliable because it runs synchronously on the same request that the queuable is running on. We wrap up the queuable job and then reuse that same request that's already in flight because we're plucking the finalizer object out into the new transaction. And that could be large enough we didn't want to persist it, the other things. That'll be more consistent. Platform events and triggers are normally really fast, but they can be slow depending on multiple factors. Like if you have a slow trigger, you can slow down your whole event stream. It's not out of the question that Salesforce will have delays processing things. Anything that's async, we potentially can have delays on.
Right.
So this will be a lot more consistent, and I would say usually faster, but platform events are fast enough they might tie and occasionally win just by convenience, but it's not going to be 100% reliable in terms of execution time like a finalizer would be.
I see.
And also, do you want to serialize your whole job state to a platform event where potentially anybody can see it if they're listening to Comment D? One of the things that we love about finalizers and queuables is you can put things that are semi-secret in there, and it's not something that can be readily extracted other than via the Apex that's actually running in that context.
Yeah, that's good use, yeah. So shall we go into this example?
Yep, and then we'll take the next question when we get a break.
Right, so this is just an extension of the previous example that a class is implementing both finalizer and queuable. The only extra step here is there is an infinite loop in the queuables execute method, which is going to cause the CPU limit error. Right before that, it is attaching a finalizer. If you see that in the execute method of the queuable, there is a finalizer attached, and then this infinite loop is started. Eventually, it will run into CPU limit error. This is something that you cannot catch because it's a limit error, but it will still make sure that even the queuable failed, the finalizer executes. If you see the finalizer code, all it does is it will check if the parent job is success. It is saying job completed successfully. Otherwise, it is printing that exception message, and it is trying to enqueue the same queuable again. Now, here is an interesting thing, undocumented thing. If this happens 5 consecutive times, after the 5th time, the system will not allow the queuable to be re-enqueued again, so that there is no infinite loop in the finalizer caused by the finalizer by re-enqueuing the queuable forever. So there is.
I have some bad news for you. You're wrong. It's documented now.
Oh, it's documented. Yeah. Okay.
Yeah,
Right.
we did document that.
Okay, so that's a recent update happened. Yes. So the queuable chaining here is like previous model where queuables enqueue queuables, and once that queuable is complete, that is a different async process. The next queuable, even though it's enqueued, it's not immediately run. It's a different async call. Same way, when this finalizer enqueues a queuable, the finalizer completes here, and the control goes back to the system. That queuable kicks in when that comes up for the execution. So it is not on the same thread, but the finalizer itself, this finalizer itself runs on the same thread as the previous queuable because it's parent attached state. So that's the general execution process. Wi-Fi. Well, a queuable, when it actually fails, internally the system tries to execute it 3 times before it calls it a failure. That is, before a finalizer is executed, in fact, a queuable is tried 3 times internally to the system. So if a finalizer is executing that and finalizer deems that, hey, my parent job came back as error, not success, that means queuable has already been tried 3 times. So if we are doing it 5 times, the queuable has been tried 15 times, and it's not succeeding, means either the implementation or some state in data is causing it, which requires somebody to take a look at it. So you will get the messages in general when queuable fails. So that's how that's the limit is determined. Chris, do you want to add something there?
Yeah, I was going to say there's some caveats on the 3 retries. So once we start executing Apex, because we realize it could have a side effect like a call out or a big object write that are non-transactional, we won't retry once it's already started executing the Apex. But say we have a Salesforce error, the database is in maintenance mode, your org is currently undergoing a migration, there's a performance degradation, we shipped some really bad code in a patch that we're currently doing an emergency release to fix, whatever it is, we'll retry if it's a Salesforce internal framework before your Apex starts executing. But I came up with the 5 and it was pretty arbitrary. So part of it is we didn't want to do an excessive number of retries. We didn't want to make it to the point where you could shoot yourself in the foot such that you could exhaust your org's daily async limit via mismanagement. That's one of the reasons the queuable chaining limit is on development orgs, is to stop you from exhausting your entirely daily allocation with one piece of bad code. We figured 5 was a good magic number. That 5 gets reset once one queuable job in the chain is successful. So that's, if you retry the same job 5 times and it's still failing, and you try it a 6th time, we probably should stop you from shooting yourself in the foot. If you would like to let us shoot you, if you would really like to shoot yourself in the foot, put a no-op job in the middle of there. So that there's 5 failures, 1 no-op job success, that resets your counter. So we built this such that if you really want to shoot yourself in the foot, you can. You just got to go out of your way and turn the safety off yourself. 5 felt like a good number for that.
And it's the chain, not the class.
Right, it's the chain.
Yeah.
So the next queuable that's in queued after, so queuable A fails, finalizer retries queuable A. Queuable A fails again. That is now 2 retry. That is now 2 failures. Finalizer enqueues a totally different queuable, queuable B, that in turn fails. That is now 3 failures. We had 2 of queuable A and then 1 of queuable B. 3 failures in a row. That means the chain failure is at 3.
Thank you.
So one of the advantages of using Finalizer for queuing enqueuing jobs is, as Chris mentioned earlier in one of the slides, if queuable itself fails any enqueuing you do in the queuable will not happen. Whereas if you enqueue it in the finalizer, even if the parent queuable fails, the enqueuing is guaranteed to occur because finalizer executes after the queuable. So that's about this example. We can go to the next example.
All right.
So this is a logging finalizer, which demonstrates the mutation that can happen in the finalizer and the ability to use that state later. The right side part of the slide has the queuable implementation. The left side one has a finalizer implementation. If you look at the finalizer implementation, it has a buffer. That log message is a custom object. It just has like 4 fields, date, string message, and request and source. That's at the bottom. So this finalizer is exposing a public method add log where you pass in the message and source. Source could be something that you want to, it could be your queuable class name or a method name or some kind of context that you want to add in, and some general log message. The date and request ID are automatically filled in. Now, if you look at the finalizer's execute method, which executes after the queuable, all it does is it checks whether the buffer is not empty, not even checking, it just goes through the buffer and commits it. It just sets the request ID because the request was not set at the time of adding the log messages in the add log method. But that request ID is nothing but the parent queuable job ID. It is setting it and then it is writing it to the database. So even if queuable fails, this log buffer is not lost. This database inserts will go through and the log will be retained. If you look at the queuable, what it is doing is it is attaching the finalizer and it is adding a log message and it has an infinite loop to cause a CPU limit error. So this is a very basic example which demonstrates that even if that infinite loop, when that infinite loop causes the CPU limit error, still that add log message, whatever was added to the log before that loop started, would still be persisted. You could have a log method add log call in the while loop as well. Every time the loop is iterating, you can add some more log content to the buffer. At the end of the queuable error, like whenever it hits the CPU limit error, this finalizer would persist all the log that has been added to the log buffer. So this demonstrates that you attach the finalizer in the beginning of the queuable execute, but you mutated its state when you called f.add log in the queuable execute, and that state will be retained and used by the finalizer when it is persisting the log
And
to the
you don't have
database.
to do anything other than mutate that state, and it just gets absorbed into the finalizer implementation. The other nice thing about this pattern is if you're worried about things like DML rows or number of DML operations, well, suddenly if you've added logging, you're no longer making your logging itself a potential risk for that.
Yeah.
Yes, in theory, it could count against your heap or CPU limit, but in such trivial amounts that you were already in trouble before this anyways.
So this could be a good time to look at the questions. There was.
Yeah, so there's been a couple of questions coming in. First of all, Rob Davis asked, in a managed package context, excuse me, is it possible to attach a subscriber-defined finalizer to a managed package queuable? And would this finalizer have access to everything that the managed package would?
So yes, but with a big asterisk, because ultimately code that's executing during the queuable has to attach it to the finalizer. You don't attach the finalizer at the point you're enqueuing the job, you do it during its queuable execution. The managed package would have to give you an interface or a property or some other way that you say, this is my finalizer that I want you to execute, and attach it on your behalf, because there's not a good way for you to add a hook yourself there.
Yeah, I'm thinking like a virtual class that could be extended by the customer and store that in custom metadata or something, and then retrieve class name, instantiate it, and attach it.
Yeah, if you solve that logistical problem of how do you get the customer to pass you the finalizer instance that they want you to use so that you can instantiate it and inject its logic. Like if you already have hooks for extensibility here, then yes. We don't do anything to solve the hooks for extensibility problem specifically. So that's an exercise left to the reader.
Sure.
Everybody's favorite phrase. But yeah, it works. And the finalizer is executing code, Apex code. So it's going to be the same managed package access restrictions. Like Customer code would only be able to access global properties and classes. So you can have secret state, you can have global state. It's up to you how you balance those. So I'm not going to say it's trivial for managed packages to do what you're describing. It definitely takes some work and some architecture and a little bit of design, but there's no hard blockers, and it's the standard Apex rules that you know and hopefully love in terms of visibility.
Yeah,
Just make
it is
sure you
doable.
don't store anything on class level variables that you don't want subscribers to be able to see, right?
So if they're public instead of global, the subscriber wouldn't be able to introspect them anyways.
Yeah. Okay, cool.
Yeah, so you really get to choose. What do you make global?
Yep.
What do you make public? And that's your breakdown of state, just like it would be normally.
Cool. Thanks, Joe.
There was another question a little earlier from David Esposito. Are there risks of putting object instances into the finalizer state that aren't serializable? For example, HTTP request instance comes to mind.
I think if they are not serializable, they will not be serialized. Even static variables won't be serialized as well.
There is one note there, which is we're not using the JSON serializer, but we're using the binary serializer, which is the same one we use for things like when you enqueue a queuable job. We binary serialize the state. We don't JSON serialize the state. The binary serializer does things like handle cyclical loops. It can handle object types the JSON serializer doesn't know how to. I forget offhand if HTTP request is binary serializable or not.
Right. So I have to check that
before you build
myself.
an architectural pattern around it. Yeah.
Yeah.
But more things are binary serializable than JSON serializable, so that might work offhand. Try it. Let me know.
That's fine. We got snagged a couple times where like we had an exception handler where it would, try to print out the cause of the HTTP request, the underlying HTTP response or something like that, and it would hork when it got there's like in a batch Apex context, for instance. So yeah, I'd have to try it.
Right. Batch
The other
Apex
thing-
also uses binary serializer. So yeah.
One thing about the binary serializer is it will also respect the transient keyword. So if you have something that you don't want to be serialized, you can use it that way. That gets weird because then you'd potentially want it on the queuable where it would have to, like that can be a real rabbit hole to go down depending on if you overuse transient, bad things can happen. But it is worth noting, depending on your use case, the transient is a way to avoid that if you need to.
Got it.
There's another question that came from Rob Davis. Rob, you might have to clarify a little bit here. Something about how do you unit test this and just make sure you re-enqueue. If you could ask your question, please.
Sure. Just generally with unit testing, re-enqueued jobs or changed jobs, it can be kind of a pain. Would you suggest just saying if test is running test or whatever it is, don't re-enqueue the job?
They don't physically re-enqueue the job, but they do get the functionality will work. I mean, they will be enqueued, but not through the.
I mean, if the finalizer re-enqueues the parent job.
Yes, it will
so
be enqueued.
That would, yeah. So if you enqueue a queuable inside a start before a stop test that has a finalizer, that'll run synchronously when the stop test runs.
Yeah.
If that enqueues something else, then that something else will run synchronously at the end of the method, which means you can't do assertions on it. So that not a pattern I'd recommend. If you're doing a basic sanity test, it can work. What I'd probably do is mock the results of the first job. So Finalizer Context is actually, it's either abstract or you can subclass Finalizer Context or implement it. I forget if it's abstract, virtual, or an interface, but you can implement or extend. I forget which. You'll figure it out real quick if you start poking at it, and use a mock Finalizer Context. So effectively skip the first queuable job, inject a mock Finalizer Context, and then verify the chaining that way. So I would break this down into two sub problems. One, enqueue the first job, make sure the finalizer runs, and mock out the actual second enqueue, or just do a very basic sanity test with no asserts, depending on whatever's easier. And then as for a second one, I'd mock the finalizer context of the failed parent job, manually set the finalizer state, and then execute it to make sure the re-enqueue worked. That way you're only doing one asynchronous execution per test. Definitely more verbosity and a little bit more work, but you can get it to work.
Cool. Thanks, Joe.
Let's see, one other question from Dave Esposito
David.
again. The login example is something very pertinent to synchronous Apex 2. Any chance finalizers are destined to be available for synchronous execution contexts?
I would like them to be. We don't have a roadmap on when that's going to happen. Each place that Apex executes has its own service protection concerns. And so we built the Finalizer framework specifically so that we could extend it to anything else. Nothing about it is inherently opinionated to Queueable. You can, in theory, if we solve some of these problems, we could make attached Finalizer work in other places. The Finalizer execution doesn't necessarily require that the parent be an async job. It could be anything. That's why you can back request ID and exception types. So at some point in the future, we'd like to, but there's a lot of complexity, especially when we factor in for a synchronous request, adding a whole extra set of limits starts getting really problematic around service protection, denial of service, mitigation. One of the areas that's really hard to do effectively is like build your own denial of service mitigation. You kind of have to rely on ours, and that starts to get a little bit riskier than I'd like in a lot of areas. So we're going to move really slowly on that, but we want to.
And I mean, we can use big objects right now to kind of get around it, but for, asynchronous insertion, but this example here is would be very interesting to be able to attach to certain controller methods that, might exit in a non-graceful way and be able to write out the log output.
Yeah, the one that'll probably be most likely is when Salesforce functions hit GA, they're going to have an asynchronous execution model, which is, it doesn't count as a call out because it buffers the call out until the end of the request and then sends it after your Apex completes and then runs an Apex callback when the function completes. Because that has so many service protection similarities to Queueable jobs, that's probably the next place we'll implement finalizers, which also is kind of useful. Of you invoke a function, you get the response back, you try and do something with it that fails, dropping the response on the floor would be bad. So being able to retry or alert on failure would be really useful. So that's probably the next place. Async is a lot easier to do this right on, and Srikanth did a bunch of the work already of juggling all the internal Salesforce contexts properly for async contexts. That's a lot trickier to do in a synchronous context, especially when you look at like how Aura or Lightning boxcars requests together. We can't actually close some of the existing Salesforce internal contexts on those like we can with async processes. So we effectively have a halfway solution for synchronous stuff, and figuring out the other half for those is still a problem that is going to be non-trivial. Yes, -1 to boxcars. Oh wait, I'm on video. Oh no, you didn't record me saying that. Yeah, -1 to boxcars.
Oh, nothing, not at all. There's one other quick question. It looks like just a confirmation from Pradeep, in that finalizers can be used as a workaround to chain more than one queueable from the parent. And so I think we talked about that earlier.
Yes.
Yes.
So you can enqueue one async job from the queueable and then one finalizer. Be careful with this. You can shoot yourself in the foot and burn through your daily async limit by building a fork bomb if you're not careful. And this is kind of the thing where we consider it as like, you turned off the safety. If you shoot yourself in the foot, it's going to hurt. If you're careful and you build in the right safeguards against it, great. You can have your async processes fork out within reason. But just be careful. There's a reason that fork bombs were so notorious in Unix land for so long. It's really easy to build a runaway chain that's hard to try and abort all the jobs on just because they start spawning faster than you can kill them. But yes, literally, yeah, it can do exactly what you're saying. Just be careful.
That's all the questions so far.
All right. So we had a few design notes, just trying to talk through the practical implications, like what we've been doing on the Q&A. Very specifically, the finalizer does not share the Apex context with the queueable that is attached to the finalizer. That means new limits, new heap, everything other than the finalizer object itself, including statics. Statics go away. Only the instance of the finalizer gets plucked out of the original queueable execution and brought over into a brand new clean Apex execution context. Nothing else copies over other than the finalizer and the object we feed to you when we execute it. That's a great thing because it means if you hit a heap exception and we tried to run the finalizer in the same context, it would just also immediately fail. So we did this on purpose. You can put as much state on your finalizer as you want, but you really don't want your finalizer to hit the 12 meg heap limit, because then you're in for a wild ride when it tries to run. So yeah, just be aware that heap is kind of the Achilles heel of a finalizer. If you shove way too much in there, you can get into a spot where it immediately runs and then hits the heap limit, but you have to really try hard to do that. Finalizer and the queuable job that's attached to share the same request ID. If you have event monitoring, definitely make use of that so you can correlate the two of them. We also now have request ID on Apex debug logs. It's a new field on the tooling API entity. So you can potentially use that for correlation with your own custom logging if you want to. Really handy to have a standardized across the board request identifier. The finalizer instance created by the queuable is serialized with its state at the end of the queuable execution. We've talked about that to death, so I don't know if there's that much to say about it. We highlighted the fact that database transactions in queuable and finalizer are completely independent. I'm going to stress that again. They are separate database transactions. They roll back or commit entirely independently of each other. Your queuable rolled back because it hit an unhandled exception. Your finalizer can still absolutely commit successfully. The finalizer executes immediately after the queuable execution on the same thread. We talked about that and comparing it to platform events. You're ahead of the game with questions here. And this did add a new quiddity. So when you check the quiddity of your finalizer execution, you'll see it has a short code of QTXF. And also you'll notice that if you're in event monitoring. So that also means that you can tell if you're looking at event monitoring logs, because the request ID is the same between the queuable and the finalizer, you can use the quiddity field to tell which one you're looking at the Apex execution for. We had to give you a way to disambiguate the two. And also ourselves, because we use quiddity a lot internally.
Before we move forward, there's another question from Chuck, and that happens is, what happens if the finalizer explodes? CPU, time limit, heap size, extension, etc.
Then it fails and rolls back. So Chuck, if you're asking me to build a finalizer for a finalizer, I don't think I'm going to. That seems a little excessive.
I was curious. Yes.
Yeah. So we encourage trying to make the work that finalizers do fairly straightforward and lightweight. You know, if you use like the FF lib patterns, they have a unit of work class that can store a complex interdependent graph of S objects that all need to be inserted, updated, deleted, etc. in one transactional unit, but it's a serializable transaction, kind of, sort of, basically. And so something like staging a unit of work, building it out fully in the queuable, and then doing the commit of that in the finalizer without much post-processing is the type of thing we'd recommend for it, because then the chance of you hitting limits is fairly low because you're doing something fairly straightforward. All right.
That's all the questions.
Cool. Make sure you're using API version 48 and above to make sure that you have the fully GA'd version of finalizers and relevant queuable support. In theory, you can use it at lower API versions, but the support for that is pretty much best effort. If you go back to before an API version before the feature is introduced, it sometimes works, sometimes doesn't. We don't recommend it. It's not as well supported. It's not as well tested. So API version 48 and up if you want to have the best experience, please.
Oh, the GA is from API version 50, 51, 50 and above. 48 and 49 are non-GA, yeah.
All right. Thank you. I'll fix the speaker deck link in a minute after I'm done presenting. Only one finalizer can be attached to each queuable job. You can't have multiple finalizers. If you want that, then there's a GitHub project that I need to finish one of these days called Finalplexer, but it's ultimately a finalizer multiplexer. It's one finalizer that just executes a series of finalizers in turn. Nothing stops you from finishing that and sending a pull request or building your own that competes with it if you want to be faster than me. There's one thing about—
Pause you right there.
Yeah.
Sorry, there's a question that came in that's somewhat specific to the API version, and it was from Mackenzie. Are the dev environments this API are up?
Dev environments are
Mackenzie,
already.
do you want to clarify?
Dev environments are already 49 version, and the finalizers are available from 48 version 48, though they are GA'd from version 50.
I'm looking for, wait, minimize the secrets. No trade secrets on this call. I think we specify the pod version on here. Do we not? No, we don't. So use the hacky version of URL hacking, the known issue site. So not all pods. Did I get this right? Oh yeah, I had that wrong. That's why. So the internal version number for summer 21 is 232.
Mackenzie, if you want to come off mute and
Yeah.
sort of clarify your question, that'd be perfect.
Okay, I'm struggling to get a good URL that lists which pods are on which API version right now.
So Chris, they are all open beta already, all the dev versions.
Yeah, so you'll have access to the open beta. The question is whether it's GA or not. So I'm going to use an internal tool that I can't show you. So let me put that on my other monitor so you can't see it.
Yeah, I'm Mackenzie. I'm currently an admin, wannabe developer, working in that direction. So I just wanted to make sure that the dev environments we're given via Trailhead do have the ability to practice finalizers and work on this concept.
They do, but not all of the pods have the API version 50 yet. So you may be using API version 49.
Okay.
So it's a question of, has your pod been upgraded to what's 232's name again? Summer 21. So if you're on Summer 21, by default, new Apex classes will be using API version 50 and be using the GA version. If you don't have Summer 21 yet, you'll be on version 49, which is the open beta version. It's functionally identical, except for I think 1 or 2 minor bug fixes. So absolutely, you can go and get started with this. They had a fairly long open beta period to get feedback and bug fixes because this is a more advanced feature. So yes, just double check about the API version 50 before you put it in production, because by the time you're ready to, the new
Summer
release
is
will be out
version
everywhere.
52, isn't
I
it?
mean,
Isn't it? Am I mixing stuff up? Man.
I was going to say, yeah. 50 and 51.
Yeah, you're right. Okay. Oh yeah, 50's out of it. Man, I am
Oh, so
bad with
50 is
seasons.
open beta. 50 is open beta. No, 50 is.
I was going to say.
So this should be.
I guess the other suggestion for Mackenzie's question there is maybe, I mean, you're using Trailhead orgs to do your development or to learn on. I mean, an alternative would be to set up a dev hub in a DE org and just spin up a Scratch org in preview release. And so that can get you the environment right now.
Considering how close the beta version is, it's whatever your preference is. It's just, if you're putting it into production, make sure you're on 50 or above for beta level, and 52 is ideal to make sure you have the fully GA version. Yeah, thank you everybody who corrected me on my API versions. You can tell how much I use the seasonal names these days that I have to look it up in front of everybody live. That was embarrassing.
I just decided, you know what's the hardest question I can ask Chris?
The hardest
Thank
question
you.
is nothing about technical. Like, I can answer the mocking question about how to test this all day, but what season are we currently in? That's the one that got me. All right. Yeah, I think we covered everything else on here other than this one big caveat, which is because the finalizer runs on the same request as the Queueable job, in some cases it's possible like a Salesforce app server crashes or the database server goes down in the middle of this execution where the finalizer may not execute. So I can't describe them as 100% bulletproof, always guaranteed to execute. Certain categories of failure can prevent the finalizer from executing. They're pretty catastrophic. They're not things that we could recover from because your Apex object state just disappeared into the ether. But I did want to note that before you make something that like somebody's life relies on or something like that, be aware that in certain catastrophic failure scenarios, the finalizer may fail to execute if it's bad enough. If we can't get a reference to your Apex object anymore into that new context, there's not that much we can do about it.
So you sure you don't want to create a finalizer for a finalizer like Chuck was asking for?
You know, if somebody says we need to make it so that finalizers can execute via message queue asynchronously, we could look at that, but then we start looking at sacrificing the mutability. And that was one of the things that was really important here is you can mutate it as you go. because you don't know what you need to persist. One out versus the make it extremely durable, but in a way where you have to know what you want to do up front. All right. So there's some docs. The links to these I have already sent to John via a speaker deck link as well. So he will post those, I think, in the appropriate places. Question mark, John?
Yeah, that's fine. It's also in the event information for tonight as well. So
Perfect.
we'll get that all out.
I just realized I'm the only one who can click these links, and so I wanted to make sure that somebody had the ability to do so as well.
Yep.
All right, and I promised everybody a quick sneak peek at the roadmap. So what's coming up next? This is where the safe harbor slide was for. I tricked you. You thought it was going to be about the presentation. No, everything up to this point, GA, no safe harbor, no beta disclaimer. That was all good to go. This is where safe harbor kicks in. What are we working on?
I mean, if you want, I can stop recording now if that would help too. Then you can really talk about it.
And none of it's a secret. Okay, might be news, but it's not a secret. So we have a pilot that we're planning to start accepting nominations to at the end of the month for user mode database operations. So these are new database methods in Apex that automatically enforce CRUD, FLS, and sharing. They're compatible with some upcoming pilot features from another team called Record Access, where they're building restriction and scoping rules. So if you ever have something like GDPR concerns about your community users being able to see each other's email addresses, restriction rules are something that's designed to solve that type of problem. You can think of them as kind of conditional field level security lockdown. And it's not something that we could express accurately in the existing CRUD and FLS paradigms in Apex. Whereas the user mode database operations feature, because it truly de-escalates you out of system mode, does everything just like your user would outside of system mode. So staring at a couple of people who I know are ISVs in the audience, all the work that you do for manual CRUD and FLS checks in your App Exchange security review, as long as you're not needing any permission escalations on top of that, you could throw that away and just do it directly with user mode database operations and have it be fully secured to App Exchange guidelines. I realize it's not 100% of your database operations, but for where it is what you do, it is substantially faster because Apex is just de-escalating out of system mode instead of making you do redundant access checks on top of system mode. It's substantially simpler. And ultimately, if it breaks, you can yell at Salesforce because we ship the feature instead of it being a framework you built yourself. Right now for the pilot, it's a dynamic API. So like database.insert has a new overload with an access level parameter. Database, same thing with database query, database search. Notably, this will have full support for SOSL, polymorphic lookups, and all the other fun edge cases. You may have noticed with security enforced has limits around polymorphic lookups because we couldn't get the checks that we were doing to be fully understood in like the raw SQL layer of the database, where it's doing polymorphic lookup security evaluation on things like task.what, where you get the object permissions that factor into that decision. Because we're actually de-escalating your permissions for the sake of this execution, but for the sake of this operation, not the whole Apex context, I should say, you don't have to worry about those, they just work. We're planning on full support, compile time support. So you'll be able to do things like insert space as space user, and then your S object to have it do a user mode database insert. And we're gonna have square bracket support as well. So you can do compile time SOQL queries, not just dynamic ones. But this ultimately, we wanna make it so that developer mistakes are hard to subvert application security with. And to that note, in the distant future, we have not determined a plan on how we're going to do this yet. So feedback is very welcome. We do want to make this the default. Obviously, it has to get to GA. We're going to let it be GA for quite a while before we look at making it the default. But we would like to make this the default so that when you start writing Apex code, you don't get the nasty surprise that CRUD and FLS were something you were responsible for. Instead, if you want to escalate into system mode for database operations, that's an explicit decision you make. Hoping we'll get some people to sign up for the pilot when it opens up at the end of the month.
So how do we apply for it, or is it just the normal way to get into the pilot?
It's a normal pilot. So we kept it as a
Okay.
closed pilot where you have to get a nomination because we want the freedom to make breaking changes. If we got something wrong in any of the design of this feature, because we're going to make it default in a far distant future, we want to get the fundamentals right. So we're starting off really cautiously with a closed pilot where we can make breaking changes if the feedback requires us to. And yes, Daniel Bollinger just put a link to the Trailblazer community group into the chat, which is referenced in the release notes. So you can join that group, follow me on Twitter, whichever you prefer to hear updates. Beyond that,
before we go there,
okay.
before we're back, can we double back to transaction finalizer? There was a comment from Rob, or a question from Rob Davis. He was saying there's a comment in the bottom of the developer docs. He says, do you have examples of what not to do? We urge ISVs to exercise caution in using global finalizers with state muting methods in the packages. If a subscriber org's implementation invokes such a method in a global finalizer, it can result in unexpected behavior. Examine all state mutating methods to see how they affect the finalizer state and overall behavior. Want to clarify that? Rob, any other thoughts on that or clarifying thoughts on that?
Basically, just what to look out for when writing these things, so that once it's packaged up, things aren't terrible.
It's really it's similar to just anything global. You have to really think about what your customers can do with that API. Except in the case of finalizers, it's probably state you're sharing with your customers if you're letting them touch your finalizer. So don't expose any mutations that are unsafe or that could step on the toes of your core processing. And once it's in there, just like anything global, it's in there. So something like an add log method that we saw earlier in the session, probably fine. It's an append only decision. There's no ability to clear out log messages that you were relying on being there yourself from your own managed code. Other than like denial of service via like excessive add log hitting heap limit, which congratulations, your customer shot themselves in the foot. Tell them to stop doing that. Doesn't really have much risk to it. But if you let them clear the logging state, that could be something that interferes with the process of your application. Just make sure you think carefully about what state is mutable by your customers and what state you're relying on not being mutable by customer code.
Cool, thanks for that.
There's not like a set of specific bugs lurking here, but it's if you accidentally expose something that's global that mutates state and then try and walk it back, that gets real ugly real fast. To Rob's question, is SecRev fee going to drop when this releases? As probably a sarcastic question. I have no idea, but if it makes things substantially cheaper for us to process, it might. Hard for me to guess. We're gonna have to see how well the pilot goes before any conversations around that happen. I would expect nothing to change for quite a while on that, realistically, though.
That was sarcastic.
You might be right though. It might actually, if we do it right, it could save enough money on manual reviews that if you never escalate to system mode in Apex, you might have an application that's a more speedy and minimalist cycle. That's something the App Exchange security team would love to do, is kind of have a rubber stamp, this complies with all of our best practices, we don't have to look at it mode, versus this is a complex total conversion that needs a more nuanced look. I'd love to help make that possible for them.
But just to confirm, you are going to tell the SecRev team that this is allowed and this will solve.
Not just that.
They will get the memo. Is really what I'm asking.
So before the pandemic hit, one of the last things I did in person was get the SecRev team stakeholders and the product security stakeholders into a room with me, where I went, I'm not talking to both of you at different points in the release cycle to figure out what's okay. We need to make it so that we all follow the same process. And since the board of directors has mandated that everything that ships has a security review, maybe we should all just attach to that process and like do the AppSec and the ProdSec review at the same time. And they went, yeah, that makes a lot of sense. And since then, that has become the standard for platform. So yes. And by default, that should be the default. If that's not, then please let me know, because something's gone very wrong. That should be our standard process. All right. Oh, I'm already over time, aren't I?
There is no such thing. You go as long as you want.
All right. So this is the pilot we're working. We just broke ground on trying to get this into winter 22. This is the one that's actually safe harbor because it's not dev done yet, but we want to get MuleSoft's data weave language supported in Apex. What is data weave, you ask, as a non-MuleSoft user who's a Salesforce developer? It's a functional, very lightweight language that MuleSoft built for doing data transformation, conversion, and parsing between data formats, and just general massaging and manipulation of complex data structures. It natively supports things like CSV, XML, JSON, supports Java object serialization, and a dozen other formats that I can't even think of off the top of my head. So what does it look like? On the left, we have some JSON input. In the middle, we have a extremely simple JSON or extremely simple data weave script that just says the input is JSON, and I would like the output to be CSV with no header. And then we echo the payload. And data weave, by natively understanding both formats, does all the work to do the conversion for us. So something that would have been nothing short of a nightmare built in Apex historically, building an RFC compliant CSV generator that handles special characters properly is not fun or performant, suddenly turns into 5 lines, of which 2 are boilerplate. There's more examples. You can do transformations on the payload directly in flight. You could do things like strip out the age field, convert it to, convert it to a birthday from the age or something like that, depending on how you want to handle it. It is a functional language, but it's the one that's designed for working with data structures performantly and very, very simply.
That is
no
brilliant.
zip.
Bravo.
Dan, to your question, no zip support, but Salesforce functions are kind of the answer for zip support. And if I get my way, data weave will be supported there. We'll see if that happens, but it's on my agenda. The idea of having data weave supported both Salesforce functions and Salesforce in Apex means that you can use the same transform and serialization and deserialization tools in both. That would be really handy. Jake, to your question, no, this will be a feature that's baked into Apex. So if you have the ability to author Apex in your org, you will be able to use this. So what we're doing is taking the tool from MuleSoft and bringing it into Salesforce. But because of the constraints on it, because we still have a heap limit, because we still have CPU limits, we don't see it as like cannibalizing MuleSoft market share. We see it as taking a best-in-class tool from MuleSoft and making it a more standardized approach across all of the Salesforce different clouds. So no extra cost is the current goal. Obviously, it's going to pilot and not a GA feature yet, so I can't say that with 100% certainty, but bluntly, I'm not really interested in trying to get a SKU created for this. It's a lot of work. It probably costs Salesforce more to charge for this than it's worth. So I'd like to just make it free to everybody as part of Apex. Also,
There was a
the JSON utilities in Apex today are not super fast, so this probably saves us money if you use a better tool.
So there
Was that, John?
There was a question from Daniel Bollinger. He was asking if the output on the right would actually have a carriage return between 45 and change.
It probably should. Yes, probably. Is this a screenshot? Yeah, it's a screenshot. All right, I was gonna go test it, but I am too lazy to type that out by hand. I'm sorry. For anybody who's curious, if you want to go play with Data Weave, this is a website the Data Weave team stood up. It has documentation and a live sample. So my Data Weave is terrible, so I'm not going to try and live code in front of you because that'll probably end up hilariously. But if somebody else would like to play with it, that is the link to go do so before the pilot is ready. And this runs entirely in the browser. You don't need a license for it. You can go play with Data Weave as much as you want in this tool, free, everybody.
So how would it look inside the language? I mean, would it be just similar in the way that inline SOQL gets into Apex, or is
well,
it
I'm happy you
file that
asked,
we
John, so that I
reference?
can advance to the next slide.
Hey, why don't you advance to the next slide?
So we're going to create data weave as a metadata type. I have a mocked up example of VS Code with a data weave folder, and we have our foo.dwl script, which is dead simple to fit on a slide. And then in Apex, we're actually modeling it after the flow interview API, because we really like the fact that you can do a compile time binding. As you see, dataweave.script and then .foo being the name of the dataweave script gives you a compile time binding that can be spidered during packaging and dependency detection, or much like the flow interview create interview, we have dataweave script create script that does a dynamic format where you pass in the name of the dataweave script as a string. This is actually the one we're going to support for pilot, because adding the compiler bindings takes more time, and we wanted to get feedback on the basics. But when we go GA, we're going to have this compile time format as well. So you'll upload your dataweave script as metadata and then reference it in Apex. Potentially, we'll expose dataweave in more things, like I can imagine dataweave and flow. If you ever want to use external services, trying to build JSON and flow is interesting. It's a fun challenge to try and get that to work performantly. But if you could do pre-processing on all your primitive objects with the dataweave script and then plug those into an external service, especially where dataweave is running at near Java speeds, that's a lot more appealing. Yep. We took questions as we went, and we're over time, so I don't know that we actually have, if anybody's got any more, we can take them.
Do you picture supporting dynamic scripts for dataweave?
It's a good question. We have the technical capability. The question is, do we want the ability to do it dynamically at runtime? And the security team really hates the idea of self-modifying code. So we're at a crossroads in my mind there of, we could do dataweave scripts that are arbitrary strings and not uploaded as metadata types. But that would probably in the long term preclude really tight Apex type couplings. The dataweave language has the ability to like inject Java types into it and call their methods as like custom extensions, basically. And I'd like to extend that to Apex types. So you can pass in an Apex type and actually use Apex methods in dataweave in the long distant future. That's not part of the pilot. That's not going to be part of the GA. But as we iteratively improve on it, that's a door I'd like to leave open. And if we allow self-mutating code database scripts, then that probably closes that door from a security perspective, because then it's effectively self-modifying Apex. So I probably at the product level, we're going to say we don't expose that. But if you have a really killer use case, you can talk to us about it and we can take a look at it.
Yeah, it's mostly about friction, right? If you want to let end users configure this stuff, you don't want every admin to have to mutate metadata files just to make small changes to the transformation. So I'm just imagining the user case and how to make it low friction.
You could also do something like passing a config object from Apex into the script and then evaluate that in the dataweave script. So having them edit the dataweave file might not be optimal. Passing in more context to the script that you process as part of it might be the right way of handling that.
Thanks.
Cool.
Chris, we have a question from Rob. What level of nuance do you plan on supporting with user mode database operations, with sharing but not CRUD, FLS with CRUD but not FLS, stuff like that?
So right now, we're not going to make it granular. You are either in system mode, whichever flavor of it you have declared on the class. So with sharing and without sharing are both still system mode, but they're system mode of different levels of power. They're system mode with the safety rails on versus safety rails of sharing off. For user mode database ops, we're just going to take you out of system mode back to the raw rights of the user that's executing the code. But once we get the baseline feature to GA, we are looking at the ability of specifying a permission set as an elevation on top of it. So one of the things that I really want to do, and we haven't done a lot of legwork on this yet, so maybe somebody will tell me I can't, we'll see how this goes, is have it so you do a user mode operation with a permission set that represents application level permissions. So I came from Financial Force. There's a set of permissions that are required to post an invoice. We might not want to give those to the end user. They involve things like create transactions, which the end user shouldn't be doing because accounting ledger and all that fun stuff. Defining a permission set that we escalate only for the sake of that DML operation and not for anything else that the user does is kind of the holy grail that I'm shooting for here. So instead of doing everything in system mode where you have all rights to all things, you go to user mode plus an optional permission set that defines the escalation. And that way the escalation of what you're doing is something that admins can audit and interact with. They can inspect permission sets. That's a concept that's familiar to them. But it also means that when you go through security review, they're not inspecting code that has access to everything by default and needs to stop itself from being abused. They're looking at code that runs as the user with a bounded prescriptive set of extra rights on top of it. Does that answer your question, Rob?
Yeah, that makes sense.
Yeah, I don't want to actually split up CRUD, FLS, and sharing on it, because I think if you want to bypass sharing, put that on the permission set, so that's part of your bounded escalation. Dan, it sounds like you're asking to be nominated to the pilot with your question, because I'm going to need more info from you on that one. It sounds like you would be glad to share it. Yeah, if the chat doesn't get preserved, Dan's question was, would need more flexibility in terms of including and shipping permission sets and packages for different editions. He's probably very right. I'm curious to dig into that more with him as part of the pilot. And because we aren't doing the permission set escalation as part of the initial pilot, it's not super time sensitive, but I am really curious so that I can go start talking to the right teams for probably next fiscal year's work. I think that's all I got. I have a thank you slide.
Last call for questions. Going once. All right. Chris, thank you very much for coming out. We really appreciate it. Really appreciate it.
The flight out to Virginia was a killer. Oh, wait.
Yeah, no, yeah. Yeah. For those who want to know, we definitely are going to clean up this recording. As Ohad said to begin with, we're going to remove the whole slide that talks about, the make buying decisions based on existing things. We're going to remove that completely. And then after that, we'll post this to YouTube. I'll tweet out the link and we'll email everybody that signed up and registered for this event with the details for that. So, and if there's nothing else, Chris, thank you very much again. Appreciate it.
Gladly. It's fun. I enjoy getting to talk about the cool stuff we're doing.
There you go. We'll have you out soon enough again. All right, folks. Thank you very much.